Welcome to the video lecture for section 2-3. This is Enlighten and Deceive. And this is for statistics 2023. My name is Jorge Young. So the key concept here is we're going to go ahead and introduce some other common graphs that we're going to learn in this course that will allow us to better understand the data that we're looking at. We're also going to discuss some of the graphs that are deceptive because how they create impressions about data that are somehow misleading or completely wrong. And then we're going to use technology to create some of these graphs. One of the things that I'm going to do is show you how to create some of them. So I'm going to create this video and then do the same thing with a video just with Excel. So the first graph that we're going to look at is a dot plot. And this is simply, this is a graph of quantitative data. In which each data value is plotted as a point or a dot above a horizontal scale of values. And so we have access to this data set, and we're going to go ahead and create this. I'll show you how to create this particular graph. So some of the features of a dot plot displays the shape of distribution. So here you can clearly see the shape of the distribution. So if you were to draw a line from left to right, you can see that it almost looks like a bell curve, not quite, but almost there. And then it's usually possible to recreate original lists of data values with a dot plot. The next one is a stem plot or stem and leaf plot, usually what they call it in middle school and high school. And again, this is quantitative data separating each value into two parts, the stem and the leaf. And so again, this is pulse rates. And so you can see that the 4 on the left with the line, and then the 0 represents 40, and then the 4 and the 2 is 42. So each one of those digits on the right represents an individual person. And again, if you were to take this and kind of flip it 90 degrees up, you can see we can also do the shape of the distribution of the data by using a line to draw a line through those data points. So some of the features of stem plots shows the shape of the distribution of the data, retains the original data values, and the sample data is sorted and arranged in order. The next one is a time series graph, and this is pretty much what it means. You can graph data in that's related to time, and so time always goes on the horizontal axis, and so we can do time in terms of years and days, hours, minutes, depending on what it is that we're trying to graph. So this again is quantitative data that have been collected at different points in time, such as a month, a year, days, hours. And so some of the features, it just reveals information about trends over time. So if something has been increasing for the last, let's say 5 years, we can see that if we were to plot it, or decreasing, we can also see that. The next one is a bar graph. So a graph of bars of equal width to show frequencies, categories, or qualitative data. And so we mentioned this today in class. If we're talking about a qualitative data, such as sex, male or female, we would represent that in bar graphs. So the bar graphs, now it says here the bar graphs may or may not be separated by small gaps. If it's not separated, it's not a bar graph. So we will always create bar graphs with some separation. Some of the features shows the relative distribution of qualitative data, so it's easy to compare the different categories. Now, the next one is the Pareto Chart, and this is simply just a bar graph for qualitative data with the added stipulation the bars are arranged in descending order according to frequencies. So when you see a Pareto chart, the first bar will be the tallest, and then the next one will be the next tallest all the way down to the smallest or the shortest bar. Some of the features shows the relative distribution of qualitative data, so it's easy to compare different categories, and then draws attention to the most important categories. So here's a Pareto chart, and you can see it goes in descending order. The next one is a frequency polygon, and this is just a graph using line segments connected to points that are located directly above class midpoint values, where I showed you how to calculate the midpoints of classes. And a frequency polygon is very similar to a histogram, but a frequency polygon uses line segments instead of bars. So now, a variation of the basic frequency polygon is the relative frequency polygon, which uses relative frequencies as opposed to frequencies on the vertical scale. And here's a frequency polygon for the McDonald's lunchtime service in seconds. So this is the data that we've been kind of messing around with a little bit. So here's a relative frequency polygon, and you can see that the vertical scale now went from frequency to percent. And of course, we can use this to compare two different companies or two separate data sets. So graphs that deceive. So non-zero vertical axis, a common deceptive graph involves using a vertical scale that starts at some value that's greater than 0. And what this does is that it exaggerates the difference between groups. And so here's an example. The one on the left starts at 10%. The one on the right starts at 0%. And you can see that, although there is still a difference between both of these. When you start at 0, it's not as exaggerated as the one on the left. And unfortunately, the one on the left is usually what you'll see in a newspaper, magazine, or online. So always examine a graph carefully to see whether the vertical axis begins at some point other than 0. And if it starts at some point other than 0, kind of look at it with a critical eye. Pictographs, this is drawing of objects called pictographs, are often misleading. Data that are one-dimensional in nature, such as budget amounts, are often depicted with two-dimensional objects or three-dimensional objects. And so by using pictographs, artists can create false impressions that grossly distort differences by using three simple principles. When you double each side of a square, its area doesn't merely double, it increases by a factor of 4. So when you double each side of a cube, its volume doesn't merely double, it increases by a factor of 8 by nature of the formula. And so here we have a pictograph. So you can see that 37% as compared to 18%. And so the 37%, although it's larger than 18%, it just seems way larger as opposed to if you were to maybe use a bar graph. So some concluding thoughts. So in addition to the graphs we have discussed in this section, there are many other useful graphs, some of them which obviously have not been created because technology is being created all the time. New statistical methods are being created. New ways to visualize data are being created. So who knows what the future holds. And so Edward Tufte is the, he's the guru of visualizing data. And so he wrote several books on it. And so these are some of the points that he always emphasized. For small data sets of 20 values or fewer, use a table instead of a graph. A graph of data should make us focus on the true nature of the data. So emphasize on the data, not on other elements, such as some funky colors, some 3D stuff. We don't want to do that. Don't distort the data. Construct the graph to reveal the true nature of the data. And then almost all of the ink in a graph should be used for data, not for design elements. So if you're spending more time, making your graph look pretty, then you might be distorting the data. And that's the end of 2.3. Thank you.